Let's have a look at this network flow diagram. And what we're going to do with this one is first of all we're going to determine what the maximum flow of this network is from A. Okay, so basically A is the source and Z is the sink. So we need to determine first of all what the network, what the maximum flow capacity of this network is. But secondly, what we're going to do is we're going to also choose a particular edge or any edge, but we need to justify it. Which edge would you increase to increase the total capacity of the network? Okay, so one of the edges will have more of an effect on increasing the flow capacity of the network than say other edges. Okay, so let's work out first of all what the maximum flow capacity of this network is. I mean, look, you could use the minimum cut maximum flow theorem if you like, but we're just going to do this the algebra way or the numerical way. So first of all, let's have a look at paths from A to Z. Okay, the most direct path is AZ, obviously. So, and that can flow 18. Okay, so we subtract 18 and it becomes 0. Okay, another slightly less direct path is AXZ. Okay, and that can flow 27 because the smallest number between the 30 and the 27 is obviously 27. So it can flow 27. So that becomes a 0 and the 30 becomes a 3. So that means that AX still has a little bit of spare capacity left. Okay, chances are that probably one of these edges might be a little bit too big. Some might be a little bit too small. So that might give you a clue as to which edge you would choose. So there'll be one of these edges will be small, will be actually too small. In fact, you'd be saturating it quite quickly, and it would appear that it would need more capacity on that edge. Alright, let's have a look at some other paths from A to Z. We've got A WXZ, but that's 0 because XZ is already saturated. We've got A WYZ. I guess we have some capacity there. Okay, A WYZ. Okay. So 62 is flowing from A to W, W to Y is 41, Y to Z is 36, so we take the smallest number, which is 36, and then what we do is that we subtract 36 from 41, okay, and that gives us a remaining capacity of 5, and 62, where are we, 62, okay, we're going to take 36 away from that, and we get 25, okay. And obviously 36, we take 36 away from that and we get 0. So that's it. We've now saturated all the inflows to Z. Okay. So in fact, one of the paths, actually two of the edges did not get used at all. In fact, so WX and XY didn't even get touched. So increasing WX or XY is actually not going to make any difference at all because we're not even using them. So we'll definitely need to increase the capacity of an edge somewhere. We could increase AW, but well, we've already got spare capacity there, so there's probably no point anyway increasing that one. We'd probably need to increase one of the ones that are 0. Okay, so in other words, if we increase the ones that have a green number other than 0, higher than 0, so increasing WY probably won't make too much difference there. Okay, we could even maybe increase XZ, okay, because increasing XZ, we could in fact take advantage of AW because AW has the most spare capacity, okay, and WX has quite a bit of spare capacity there, okay. In fact, well, XZ, I would increase XZ by 23, okay, because we then have a path AWXZ, okay, which will in fact increase the flow by 23, okay. So that way then we're taking advantage of these two edges that have a lot of spare capacity left, okay, and this edge here, xz, obviously can be increased. So that would be the one edge that I would choose. If you increase yz, for example, you need to say to yourself, well, if yz is increased, we could have a path awxyz, but the xy is quite small, and that's going to limit it to just a sort of just an extra 9 units of flow. So I would choose, okay, xz to increase, okay, and because, okay, awxz has the potential to flow another 23, okay, because the path, okay, awxz, right, has the potential for another 23 units of flow. Okay, and I would increase xz by 23. Okay, so in other words, instead of it being 27, I would make that 50. Okay, so in other words, if I was to make that edge originally 50, all right, and then we took 27 obviously away from that, okay, that would leave a spare capacity of 23. Okay, so this is the path AXZ, so AXZ. In fact, in doing so, you would also increase, you would actually use up this capacity here as well. So going back over that, I could actually use up this one here. I would actually increase it by 26, in fact. So just think, sorry, I'll just do that in red. Okay, so that's why it's good to think about this a little bit, to think, okay, is there anything else that could potentially flow into it? So let's make that then 53. All right. So let's see what happens now. So AXZ, okay, we would flow 30. In fact, we could flow the whole 30 into that, and then you'd end up with 23. Okay, we'd end up with 23 units of flow of spare capacity. Then this AWXZ could flow the entire. We could saturate the entire edge, or in its entirety. We can saturate WX and make that 0 as well. Okay. I'm just going to pause the video. I'm going to redraw this diagram now with a 53, and then we're going to see how just increasing that edge would increase the flow. The other thing that just got to work out as well, and sorry I didn't do this earlier in the video because I was really focused on looking at this one edge to increase, is the total, the flow capacity of this network, which is 81. All right. So increasing the edge XZ, what does that do then to the flow capacity of the network? Okay, so I'm just going to pause the video, then I'm going to flip the board around. Okay, I'm back. Okay, I didn't have to flip the board around. All I did was just redrew the weights of the edges back in again. Except this time I just changed XZ, and it's now 53. So let's see then what happens to the flow capacity of this network. Remember, originally it was 81. All right, so let's compare our sort of our new network with the old. All right, let's have a look at the paths from A to Z. We have path AZ, which is 18, of course. So that hasn't changed. Okay, so we're going to subtract 18 from that. All right, now we've got AXZ. Okay, AXZ can flow, in fact, a full 30. All right, so we're going to subtract 30 from everything now. So that becomes 0, and that becomes 23. All right, now we can look at AWXZ. Okay, and AWXZ can flow 23, in fact, since we've increased XZ. So that becomes 0, that becomes 0, okay, and 62 minus 23, my brain's getting a bit tired now, so that's going to be 39, okay. Do we have any other paths from A to Z? Yes, we do. A, W, Y, Z. Okay, A, W, Y, Z. We have 39, 41, 36, so that's going to be 36, obviously. And we're going to subtract 36 from everything, so that's 5 and that's 3. Okay, and lastly, do we have any other spare capacity? No, we don't. There's no other way to get from A to Z. So adding up these numbers, so we've got 18 plus 30 plus 23 plus 36, and we end up with 107. Okay, so that's an increase of 26 extra units of flow. Okay, so that's most certainly made a significant difference to the flow capacity.